Almost forgot to start the recording there. So on this one, what's our first step? Okay, yes, we're going to look at the common rafter. And yes, we're going to be finding, this is 40 feet. This is a 9/12 slope. We have to find H and J. You're absolutely correct. How do we find H? Okay, so it's 9/12 equals H over 20, which gives us what for H? 15 feet. So then for J, what do we get? It's the square root of 20 squared plus 15 squared, right? Which is 25 feet. So here, this is 25 feet. Is that common? Which means our longest jack is the same as the length of our common. It's also 25 feet. Now what? Let's find the length of the hip, the corner, right? How are we going to find that here? We have that triangle. We know this is 25, right? What else do we know? This is 20. So, how do we find this one? Square root of 20 squared plus 25 squared, which gives us? Here, so let's do this. Second square root 20 squared plus 25 squared. 32.015, so it's 32 feet. Subtract the 32 times 12 is going to be less than an inch. So times 16 is 3/16. So yes, 32 feet and 3/16 of an inch. I'm going to write it down though. 32, well, we'll leave it. That's the corner. We don't need that for anything else. So we're good there. How do we find the jack rafter decrease? So, yep, we have that triangle. It's 25 and 20. Next one is going to be a little smaller. Oops, shoot, that's not what I wanted. That's the two. What size of which piece of this do we know? We know this side's going to be what? If we're assuming 2 foot on center, that's going to be 18. So I'm going to call that X for now. That'll be the second jack is what we're finding there. So what's our proportion? 18 over 20 equals X over 25. 18 goes to 20 because they're both that side. They're both along the span. And X goes to 25 because those are both jack rafters. And we cross multiply and divide. 18 times 25 divided by 20 is 22.5. Very good. So the decrease, 25 minus 22.5 is exactly 2.5 feet. Or 2 foot 6 inches. Anybody get that? Do you guys understand how to get that? Okay. Let's look at a valley. Okay, a little bit less extravagant with my drawing here. This this little piece that sticks out here is what we call an L. It sticks out from us. ELL is what they spell it. So here's our main ridge on the main roof. This is the L roof coming in. Now I'm going to do this the simplest way possible right now. I'm going to call this 30 feet. And this is going to be 30 feet. So we have same span, same slope. Obviously there's going to be valleys there and there. There and there. And let's say that this is a 10-12 slope. We have similar framing. I don't have a model for this one, but we do have similar framing. We have the main rafter there and there, and then the jacks. So we have a comment on the main roof side, we have a comment on the L side, but since these slopes are the same and the spans are the same, the common here will be the same as the common over here. Does that make sense? So just like with the hip roof, our first step is to find the length of the common. So both of these will be the same, so it doesn't matter which one we start with. 30-foot span, 10-12 slope, looking for H, run of 15 feet, 10 over 12 equals H over 15, which gives us 12.5 for H. Yes, no? Yeah? So if that's 12.5, then J has to be the square root of 12.5 squared plus 15 squared. 19.526. Now I'm leaving it in the calculator because I am going to convert this. It's 19 feet. Now I'm going to do this. I'm going to actually store this. Oh, come on. I'm going to store this in location A, so I have it for later. So there's my number. I'm going to subtract 19. So I got 0.525 feet times 12 gives me inches. So that's 6 inches. Subtract the 6 inches times 16, give me 16ths. 4.9 would be 5/16. So this common here is 19 feet, 6 and 5/16 inches. That would be either side, either this one or this one. Doesn't matter which. Now, once again, to make things simpler on us, we are going to assume 2 feet on center. If I do this triangle, oh, I want to change color there. If I look at this triangle here formed by that common rafter and the valley, this is my 19.526. I am going to write it back in decimal for now. What's this length up here going to be? That's basically this length here. Thanks, sir. That's it? Yeah. Yeah. I was meant to throw you a couple easy ones. Okay, so half the 30, right? 15 feet. Because that does just go flat. Remember, the ridge is going to go flat there. The ridge doesn't slope. Right? This is 15 feet. So then the next jack here is going to be that triangle. Oops, if I draw it the right direction. This is going to be X. That's the length of the next jack. What's this going to be here? 13. Yeah, minus 2. So we have now 13 is to 15 as x is to 19.526. So 19.526 times 13 divided by 15. 16.923 is the length of that next jack. Feet. Does that make sense? Now, by the way, we could have found the length of the hip rafter here if we wanted to, or the valley rafter here. That's just the hypotenuse of this triangle, just like finding the hip. I just didn't bother because that's something you guys already know how to do. So our decrease is going to be the 19.526 minus 16.923. So we get 2.603 feet, which is going to be 2 feet 7.236 inches, so 7 inches times 16, 4/16, so 1/4 inch. So 2 foot 7 1/4 inch is my decrease. So each jack is 2 feet 7 1/4 inches shorter than the next longer one. Does that make sense? Any questions on that? Bless you. So if you're given that both spans are the same and that both slopes are the same, really no different than dealing with the hip roof. Actually, no different at all. Just the picture's a little different is all. So now on the hip roof, what if I give you a picture that looks like this? What's that tell us? It's not 16 feet high. This is the setback here that's 16 feet. So that's the distance along this wall to where that ridge would be. But this tells us it tells us something about the slope of the hip. It's the same. So this is a conventional hip because this setback is half of the span. If the setback is half of the span, we know the slopes have to be the same. Does that make sense? Because we do this here, this is going to be 16 feet. So even if we're not told that the slopes are the same, if we're given that that setback is half of the span, we know the slopes must be the same. So you guys talk me through finding the decrease here. What's step one? So common. So we have what down here? 32 here. 612. Okay, and what do we have to find first? Height. What do we need to know for height? This is 16 feet is the run. Okay. So what's our proportion? See that h is 8. Then what? So square root of 8 squared plus 16 squared. $17.889. 889 is what it rounds to. We're going to leave it as that for now. That's that length. Now we know we can find the corner rafter right now because the corner rafter would be found just off of this triangle. And that's 16, right? It's just a squared plus b squared equals c squared is going to give us that hip rafter, the hip corner. The next one, what do we know on this triangle? Subtract 2, so this is 14, and that's our x. So what are we going to set up here? Okay, so what's it going to be? 14 over 16, x over 17.889. 15.652. So our decrease, 17.889 minus 15.652 gives us a difference of 2.237 feet. And I'm going to trust at this point you guys can convert that to feet, inches, and sixteenths. Conventional hip, what does that phrase mean? Slopes are the same. So here's the ridge for my main roof. And we're going to say that this is a 12-12 slope. Now obviously this is a 36-foot span, this is a 24-foot span. What does that say about our peaks? If these slopes are the same, the peaks do not match. The peak of this roof here does not hit the peak of that roof. It stops somewhere in there. Like that. It only goes partway up the side of the roof. To deal with this, we're going to take this valley here, and we're going to extend it up to the ridge so that we can do our math with it. Now we have two different ways of approaching this. We could find this common here, or we could find this common here. Remember, this is the main roof common. This one would be the L roof common. Does it matter which one we use? No. In fact, we're about to do this problem both ways to show that you're going to get the same answer either way. So we're going to start out with the main roof common. "36 feet, 12-12. Here's H. Run is 18. Then a miracle occurs and H is 18 feet. 12-12 slope, obviously H is equal to the run, right? So then J up here is the square root of 18 squared plus 18 squared. $25.456. Right? 25.4558 technically, but 456. So this here. Which then gives us a triangle. This is 25.456 feet. What's this? It goes past the ridge here, doesn't it? It's got to be more than 12. Since these slopes are the same, this is going to be half of the 36. It's going to be 18 feet. Which means the next triangle is going to be 16 feet. Again, assuming 2 feet on center. 16 over 18 gives us x over 25.456. So we're going to take my 25.456 times 16 divided by 18. I get 22.627. So my decrease, 25.456 minus 22.627. I'll borrow here. This will be 4 and 16. So this is a 9, a 2, 4 and 14, 8 and 2, 2.829. Thank you, sir. So 2.829. Any questions? Now let's do it from the L roof side. Make sure we come up with the same answer. This is 24 feet, 12 slope, 12-foot run, H is 12, J is the square root of 12 squared times 12 squared is 16.971. This is the square root of 12 squared plus 12 squared, right? I know I'm going a little fast here. You might need me to stop for a second to catch up?
Yeah, 1 second.
Just 1 second? Okay. So now we're going to look at this triangle right up here. What we just found is this. 16.971 feet. What's this going to be? This distance here. It's going to be half of the 24. 12 feet. So then the next one, that's going to be 10 feet, right? This will be x. So we've got 10 over 12 is x over 16.971. So 16.971 times 10 divided by 12, 14.142. So as we subtract here, 2.829, we get the exact same thing both directions. Not even a round off error. And again, that works like that because it's conventional. Same slope in both directions. So now the million-dollar question is, what if it's not conventional? Women and children run away screaming. Unconventional hip. This is going to take a while because there are a lot of different cases for an unconventional hip. So for this one, this is going to be 412 slope here, 812 slope on the hip. So we have, let's give this a 40-foot span just for fun. We still, as always, will start with the common. What do we know about our common? What's that? 412 slope. Good. What else do we know? 40-foot span. Very good. That is all we know. That's what we're going to use to find h. Of course, the run is going to be 20 feet. So h is going to be 4 over 12 is h over 20, which gives us 6.667. Somebody double check me. 6'8", but 6.667, right? 6 2/3.
Yeah.
So now for J, square root of the 6.667 squared plus 20 squared. Now when I put this in my calculator, I'm going to put in the 6 2/3 like this, so I get that decimal in there. So now when I do my square root, I'm going to do second answer squared plus 20 squared. So it's 21.082 feet. So the common rafter right here is 21.082 feet. Now here's where the similarities end. Because now there's a lot of extra steps that we got to do before we get to the rest of it, because the slopes are different. And there's going to be two calculations. The decrease here is going to be way different than the decrease over here. Notice I purposely drew them so that they didn't meet on the hip there. They will not meet on the hip there. Okay, this one's actually going to be coming in up here like that. Because the slopes are different, they're not going to meet together at the same spot on that hip rafter, that corner rafter. We'll get a different decrease on each side. So we are going to go ahead and we are going to find the main roof decrease. The decrease on the common side, sometimes called. To deal with that, we have to figure out this setback. To figure out that setback, we have to look at the longest hip jack here for just one moment. So this one right here. So I'm looking at it from the side like this. So this down here is my setback. This is my longest jack. What piece of information do I know about that little triangle right now? I know the slope is 812. Very good. There's another piece of information I know. You got it. How do I know the height is 6.667? Yeah, the peaks have to come out, right? When I'm looking at this thing here, the height on the main roof coming up here, this is the height, right? Well, that has to be the same height coming up on the hip roof right here. That's still that same height. So it's the same height no matter what direction I'm coming from. So I know that height and I know that slope, which allows me to kind of work backwards a bit. I have 8 over 12 equals 6.667 over setback. So on my calculator, I'm going to do the 6.6. So 6 plus 2 divided by 3 again to get my 6.6667. Times 12 divided by 8 gives a 10-foot setback, exactly 10 feet. Now, in this case, it's very, very common on hips to have the slope of the hip be exactly double the slope of the common rafter. And when that's the case, the setback is always half of what it would have been. So this here, the half span is 20 feet. Half of that is 10 feet. Makes sense? So we've got a 10-foot setback. So this here is 10 feet. So now back to the main roof decrease. I now have this triangle where I know this is the 10-foot setback. This is my 21.082. What else do I know? I have this triangle here. What do I know about it? 8 foot here now, and this is going to be x. So we have 8 is to 10 as x is to 21.082. So 21.082 times 8 divided by 10. 16.866. Now that we have that amazing number, 21.082 minus 16.866. This is 7 and this is 12. 12 minus 6 is 6. 7 minus 6 is 1. This is 0 and this is 10. That's 2. This is 1 and this is 10. That's 4. 4.216 feet. Again, I'm going to assume you can convert that into feet, inches, and sixteenths. We're going to stop there. Now we've got to go to the hip roof side. And find the hip roof decrease. And we're going to start with this little picture right here. We found that this is 10 feet here, right? This is 6.67, so we can find the length of that longest jack by doing square root of 6.667 squared plus 10 squared. So I'm going to get my 6 2/3 in here again. So square root of answer squared plus 10 squared. 12.019 feet. So that means this here is 12.019 feet long. So now we're going to look at this triangle. $12.019 feet, and this of course is our half span of 20 feet. Next triangle here is going to be what? So 18 feet, and this is x. 18 over 20 equals x over 12.019. So we take our 12.019 times 18 divided by 20. 10.817. So our decrease, 12.019 minus 10.817. .202 feet. So this is on the hip side. We've got a decrease of 1.202 feet. On the main roof side, or the common side, 4.216 feet. What do you think? Loads of fun? Now, the way I gave you this problem was the most difficult way I could have set it up. By giving you the two slopes, that makes it way more difficult. There is a somewhat easier way I could have set this problem up for you. I could have given you information like this. I could say this is 32 feet. I could say this is 912. This setback here is 10 feet. Now we don't have to go through that extra step of finding the setback. Still going to start out with the common. Looks familiar so far, right? So we find h 9 over 12 equals h over 16, which gives us what? H equals 12, right? So that means that j up here equals square root of 12 squared plus 16 squared, which is 20. Now I gave you some easier numbers here too, just for the sake of time, because we're getting a little tight. I want to give you a little bit of work time on these. So that's 20 feet there. Now I'm ready to jump right into finding the common decrease. On the common side. So I've got this triangle here. There's 20 and 10. Next triangle is 8 and x. 8 over 10 equals x over 20. Guess what? X is 16. The decrease is 20 minus 16, or exactly 4 feet. Now that number didn't come out clean because I gave you the setback instead of the other slope. It came out clean because I gave you really, really clean numbers here. But that is the decrease on the common side, on this side here. So this next one right here will be 4 feet shorter than that. This will be 16, 12, 8, and 4. So now it is time to look at the hip side. On the hip side, we still do have to find the length of that longest jack. The difference is we now know all the information. The setback here was 10 feet, right? The height was 12 feet. And this won't come out quite as pretty. That's going to be the square root of 10 squared plus 12 squared. Here's my longest jack there. So 15.620 feet. So this here, 15.620 feet. So when we move down to this one, well, let's do the triangles here first. This is how much here? Half of the 32, right? Would be 16. So this is 16 feet here, 15.620 feet. Next triangle, this is 14 feet, and this is x. So 14 over 16 equals x over 15.620. So 15.620 times 14 divided by 16. 13.668. So now we subtract. $1.952 feet. What do you think? Finer than a frog's hair split in two and twice as shiny? Sure, why not? Okay, in your packet. I have to grab here, so make sure I give you the right pages. Did you guys get done with the one I gave you yesterday? Finding the common hips. Problem number 1 on page 280. let's just do this. 282 to 283. Problem number 1, A through E. I'd ask you to find 1, the corner. In other words, the hip rafter, the length of the hip rafter. And 2, to find the decrease, right? So I'll leave that up there in case you didn't get it done. So next we're going to look at valleys. On page 289 it starts. It's just number 1, A through C. It gives you the main section, the width of the main, the width of the L, the slope of each section. I want you to do the same thing. I want you to find the hip or the valley corner here now, which will be the same as the hip pretty much. And to find the decrease. In fact, for that one, I'm just going to have you do A and B because C is actually a little bit funky. We haven't talked about unconventional valleys yet. And then for unconventional hips. Actually, let's keep going here on page 295. Problem 1, A through E. And problem 4, A through, that's just A and B. We're not going to do C yet. Do the same thing. Find the corner, the hip or valley corner, and find the decrease. And we're going to stick with that for now. If you do those, we'll talk more tomorrow about the unconventional case. So I'm going to give you guys your last 11 minutes to get started on those. Hopefully they go well. Any questions? The hardest part here is just the visualize, trying to see where it is that all these things really do come together. Because there's a triangle that goes this way, then there's triangles that go this way, then there's triangles that go this way. Trying to see it, draw it in 2 dimensions, but see it in 3 dimensions is kind of tricky.